In this video, we're going to be using the properties of dot products. And here we have our properties of dot products. So we're going to let vector u be components -1 and 3, vector v have components of 2 and -4, and vector w with components of 1 and -2. And we're going to use these vectors and the properties of the dot product to find the following. So in problem A, we see that we have a vector times a vector times a vector, and we don't really have a property that goes with that. But we do know that we can find the dot product of our u times v, and since that's inside the parentheses, we're going to find that first. So we have -1 times 2, and then 3 times -4, and then we're going to add those together to get -14. And now we can take that -14 and we can plug that in. And so we have -14 times vector w. And so we can go ahead and now we're just going to use simple multiplication of a scalar and a vector. We're basically going to just distribute that -14, giving us a final answer of -14 and 28. Looking at letter B, we have vector u times 2 times vector v. And on this one, we can use property number 5 down here, where we're actually able to rewrite this as 2 times vector u times vector v. We actually have already figured out what vector u times vector v is, because we did that in problem A, and we got a -14. So let's go ahead and plug that in. So we have 2 times -14, which gives us a value of -28, and we're finished. Letter C looks a little trickier since we're looking for the magnitude of u. Using property 4, we know that a vector times itself is the magnitude of that vector squared. So if we were able to take vector u times vector u, that would give us the magnitude of vector u squared. And then if we could square root that, that would give us just our magnitude of u. So let's go ahead and let's multiply our vector u times our vector u. So that's going to give us a -1 times -1 plus 3 times 3, which gives us a value of 10. But remember that in order to get the magnitude of u, we have to take the square root of our u times u. So we need to take the square root of our 10, and that is going to be our magnitude of vector u and our solution.